Okay, so we're doing the confidence interval for a paired t-test. This is page 139 of the notes spiral. So one indicator of physical fitness is resting pulse rate. 14 men volunteered for the test. An exercise device advertised on television by using it 3 times a week for 20 minutes. The resting pulse rate, beats per minute, was measured before, then tested before the test began, and then again after 6 weeks. So we have a before and after. So this is beginning to sound like we're working with a paired test. Once again, before and after, or someone tested twice, looking paired. All right. When we look at the results in the table and we see, hey, the data links are the same. So that's another good indicator. And once again, we have a before and after. But not only do we have a before and after, we have before measured for each individual. Because we have it for each individual, before and after for each one, this makes it a paired test. So I'm quite confident we're working with a paired test. And so I need to enter all this data into L1 and to L2. So it should look something like this. So here's how I got there. I pressed stat, the stat button, which is in the middle of the calculator. And then I pressed edit and entered. And then I just entered the before data into L1, after data into L2. You're going to need that. The next thing it asks us to do is create a 95% confidence interval for the mean difference and explain the meaning of the confidence level. Well, on the sheet, it says the very first thing you do is define the mean difference. So let mu d equal the true population mean difference in resting heart rate before minus after. It is hypercritical that you tell the direction. All right. You've got to tell the direction you went because your interval will change. Not the width, but it'll change from positive to negative, depending. Well, it'll change its location based on whether you do before and after. And usually it'll change from positive to negative or vice versa. You could do after minus before, but you must say which direction you went. I'm going to blow through the conditions because I did them in the previous video. The very first thing, random sample. Well, fortunately, they did not tell us it was a random sample. They said we had volunteers. All right. So I'm going to have to assume that the volunteers represent the population. All right. This is true of experiments that we often have volunteers. It is not the case for most surveys. So, but nonetheless, we have volunteers and we're going to have to assume that they're representative of the population. Our sample size was 14. 14 divided by 0.10 is 140. There are a few more than 140 in the population. Why? The sample must be less. In this case, the sample is less than 10% of the population. Once again, I did these same conditions in the previous videos. The next one, number 3, is the new condition, all right? And the new condition is differences must be independent, all right? Now, we don't really know if the differences are independent, but somehow or another, I don't think the change in Alex's pulse rate affects trips, affects Matt's, etc. So it's reasonable to assume that the change in one person's pulse rate does not affect the other. The last condition is the normality condition. And it's either they told us it was normal or we have 30 pairs of data, in which cases, or more, and normal by central limit theorem. But here we only have 14 pairs of data, so we can't say that it's normal by central limit theorem. So we need to do a box plot. So here's how I'm going to go about doing this. I have my data entered in L3. I'm going to go all the way up to the top of L3. So L3 is highlighted. All I did was arrow up. And I press second 1 minus second 2. And I pressed enter and it populated it for me. So there's my differences. So then I'll go second stat plot, press enter, arrow to the left to make sure it's on, drop down and arrow to the right until I get the box plot that shows outliers. That's the one with the dots. My X list should say L3, and I just press second followed by the number 3 in order to get that. And then I'm going to press zoom 9. And there's my box plot. Okay. As you can see, not really that symmetric, but with College Board, there's definitely no outliers. So the box plot, we're going to say it's reasonably symmetric. Probably should put these in quotes. With no outliers, the distribution appears to be approximately normal. All right, the next thing is I need to know how to get my XD and my SD. The easiest way to do that is, once again, stat, arrow over to the word calc, one variable statistics, second 3, enter a couple times, and there it is, 2.5714, and my SD 2.2434. Degrees of freedom, because we're going to need them in order to calculate our T star, is 14 minus 1, or 13. And our formula is going to be X bar D plus or minus T star SD divided by the square root of N. So let's go ahead and calculate T star real quickly, because we have everything else we need. So we're going to go second vars inverse T. And in this case, they wanted a 95% confidence interval. So I'm going to go parenthesis 1 minus 0.95, close, oops, not plus, parenthesis 1 minus 0.95, close parenthesis, divided by 2. My degrees of freedom are 14 minus 1, or you just could have typed 13 in there. And we're waiting for the calculator to think, and it tells us T star equals 2.1603. So now we have XD, SD, and we also have T star. So I plugged them in, 2.57 plus or minus 2.16. So there's my work shown. So now we need to calculate the interval. So here's how we calculate the interval. Stat test. Number 8 happens to be T interval, so I'm going to scroll down to number 8. Press enter. I'm using data. My data is stored in L3, so second 3, frequency of 1, 0.95. And I get 1.2761 and 3.8667. All right. Hopefully that shows up fairly well. So now we have our interval, and what are we? Well, we always have to have our conclusion regardless what they say. Regardless what they say, we always have to write that. So we are 95% confident that the true population mean difference of resting heart rate before minus after lies within the interval of 1.276 and 3.867. This part right here is just the definition that we did before. Okay, this was our confidence level, and this was the interval we calculated. Now, in this case, it also explained the meaning of the confidence level. So I have no choice but to do the in repeated sampling. So in repeated sampling, we expect that this method will capture, what's it going to capture? Our definition, the true population mean difference in resting heart rate before minus after 95% of the time. Now, did this show that it worked? Well, does not lie within the interval. Well, zero would be the zero indicates that there was no difference. Well, that fact that no difference doesn't lie in there means that there was a difference. So we're 95% confident that there is a difference in resting heart rate after 6 weeks of exercise because zero is not in the interval. In the interval. Okay, and that will conclude that one.